this point, sorry, let me move the microphone closer. All right, we left off at this point where we were using the sum of the geometric series to determine, to come up with the formula for the present value. So 500 over 1.08 multiplied by all of this. I'm going to rearrange this to move this 1 over 1.08 to the denominator. So now this will be 500 bracket 1 over 1.08 to the power of 5 minus 1 all over 1.08 gets multiplied to the 1 over 1.08 minus 1 to the entire denominator. Now, this 1 over 1.08, another way to write that would be 1.08 to the power of negative 1, all of that to the power of negative 5. When I distribute, what ends up happening is 1.08 times 1 over 1.08, that just cancels out the 1.08s and we get 1. 1.08 minus 1, so times negative 1, there we go. And now 500, 1.08 to the power of negative 5 minus 1, all over negative 0.08. What I'm going to do is, last thing, I'm just going to move this expression, or this negative sign, to the numerator. And what ends up happening is, instead of sticking the negative sign in front here, it gets distributed inside the brackets, and then we just switch what's being subtracted. So we get 500, 1 minus 1.08 to the power of negative 5 over positive 0.08. And so, if you see here, this 500 would really be our regular withdrawal. Actually, let me just use variables for that. So 500 I'm going to represent as R for the regular withdrawals. This 1.08 is the result of 1 plus I, and this 0.08 is I. So I could just rewrite this as R bracket 1 minus 1 plus I to the power of negative n all over I. And that is actually the present value of an annuity formula. So if you look on the next page, I'm going to just pause, flip to the next page, you can see the formula that we just came up with here. Just going to highlight it. And just like before, we're just slightly modifying the I and the n values because C represents the number of compounding periods per year. Okay, so in this formula, C represents the number of compounding periods per year, N represents the number of years, I represents the annual interest rate, and R represents your regular payment, or if you want to think about it as a withdrawal amount, it's in dollars, okay? And PV is the present value of having those future regular payments, okay? Present value in dollars, all right? So if we want to think about how much interest does Richie Rich earn, well, he wants to have the $500 at the end of every year for 5 years. So that $500 multiplied by 5. So he has $2,500 in the future, and he invested the present value amount of $1,996.36. So if we subtract those amounts, 2,500 minus 1996.36, we will get, and you get $503.64 in interest earned. So this $2,500, that's like how we calculated RNC in the previous lesson, and this PV is our new PV from this formula right here. So the amount paid into the annuity, so how much Richie Rich pays, that would be the formula up above, 1 minus 1 plus I over C to the negative and C all over I over C. And the interest earned would be calculated by R and C minus how much he invested.